This is question 13, part A, from the Mod 5 Higher Paper 1, November 2010. And it's the second question on this paper, which is a non-calculator paper where trigonometry has cropped up. So if we look at this question, first of all, it's asking us to find the area of a triangle. The area of a triangle is usually base times by height divided by 2. But then here, that would probably be the base, that would be the height. We don't know the base, so we can't find that straight away. And they have given us some information up here as well about trigonometry, sines and cosines, things like that. Well, if we look, first of all, at the formula for area of a triangle, we said there's a half base times height. But there's another formula for the area of a triangle, which is a half AB sine C. The A and B are lengths of sides. Side A is the side opposite angle A. So side A will be this 10 centimetres up here. Side B is the side opposite angle B. So B would be that 20 centimetres there. And the capital letter C here, the big C, is standing for this angle here. Well, let's have a look a minute. In this triangle, if this is C, what are these two sides in sort of trigonometry language? This would be the opposite of the angle. This one is actually the long side opposite the right angle. This is the hypotenuse. And over here, the side between the angle and the right angle, that would be the adjacent. And adjacent and hypotenuse is cos. So I know that cos of angle C is equal to the adjacent divided by the hypotenuse, which is 10 divided by 20. I know then that cos C is a half, or 0.5. Now up here it tells me there's a cos that equals 0.5, and it's up here for a purpose. Some of these are up here to confuse you, but there are useful things up here as well. If cos of C is 0.5, and cos of 60 is 0.5, that means C must be 60. So using the information up here, I now know that that angle C is 60 degrees. Which means I now know for this formula what A is, what B is, and what C is. So the area of this triangle is a half times by A, which was 10, times by B, which was 20, times by sine of C. And sine of C is sine of 60. And sine of 60 is given to me at the top. Sine of 60 is 0.866. So in a minute I can change that. Just look at this first of all. Half of 10 is 5. 5 times by 20 is 100. So this is 100 lots of sine 60. And I've just said that a sine 60 is 0.866. So I need to times 0.866 times 100. If I times it by 10, it would be 8.66. Times it by 100, it's 86.6. So the area of this triangle is 86.6 centimetres squared. Moving on to part B, this new shape, this kite, has been made by putting two of these triangles together. So this right angled triangle we've just done is this right angled triangle here. Okay, so that triangle I've just sort of gone over there is the same as this triangle here. So this triangle and this triangle are the same, which means I now know that that is 10. I know this distance all the way down here is 20. I also know that this angle up here is 60 degrees. So that's the information that I've got. I also know that the area of that triangle is 86.6 centimetres squared. And in this question, they want you to work out this length here, PR. And if I just cover up the triangle on the right, I'm just going to put that 20 back in there. If you think of this here being the base of the triangle, which is 20, this here would be the height of this triangle. So I'm going to call that H a minute for height. I'm really imagining this triangle turned this way now. So if I just sketch that out, what I'm saying is I've got a base of 20, and that is my height. Now I already know from what I did in part A of the question what the area of that triangle is. I already know the area of that triangle is 86.6. And I got that from this half AB sine C formula. But I also know that the area of a triangle is a half times the base times the height. And as it's the same triangle, half base times height also must have the same area. So now what I'm looking at is this triangle. I know the base is 20. So a half times by 20 times by the height is equal to 86 times by 86.6. Half times 20 is 10. So 10h is 86.6. So h, the height, will be 86.6 divided by 10, and that's 8.66. And that height, going back to the original question, is this distance along here. I now know that distance is 8.66. And the question was asking me all of the way along here. So it's another 8.66. And if I add those two 8.66s together, I will get the total distance from P to Q. And if you add those together, you get 17.32. So that's the final answer for question 13, part B.